All right, can you guys hear me? I should be live now. All right. Yeah, that should be cool. So I have decided to start a new project because I haven't started enough already. And if you guys are a moderately long-time viewer, you would know way back in like late 2020 probably, I started this project. The Codex Project is what it's called. There's some articles, actually, let me show you guys my screen. Make sure you guys can see my screen. Yeah. So this is the GitHub, and we'll get to that in a second. This is the website. And if you go on articles, and if you go like all the way down, not like I have that many articles or anything, but we'll let that load. And you can see these two Codex Project files. This was basically going to be like a Python cryptography suite that I was going to kind of create and yeah, I don't know. So I started the concepts for it, right? Kind of talking about I wanted to make like a Python shell script that could decode different ciphers. When was this? This was November 3rd, 2020. Yeah, November 3rd, 2020. So this project I have considered has been in the works for like a year by now, probably just under a year. But I never really started it. So I figured, you know what, let's finally start it. Yeah, if you guys have seen the website before, check it out. I just updated it the other day as a whole new interface. We actually have a cyber store now, which is pretty cool. And some future merch if we ever get to that level. But yeah, I'll leave this up in the background. But this is the GitHub page for it. I'm gonna zoom in a little bit. And this is the Codex Project. Hey, what's up, Sister? Cool. So yeah, this is the Codex Project. Again, it's a Python suite for cryptography, and I wanted to be able to encrypt, decrypt, and brute force different like ciphers, texts, and files. Yeah, that's the plan. I also want to have like one-liners implemented and stuff. Yeah, so it should be pretty fun. I think I might stream for like 2 hours today, or 2 to 3 hours, just to get it started, and we'll see how it goes from there. Yeah, all right. So let's check out the roadmap because this is what's the actual important stuff. So this is kind of like the roadmap's going to be like the overview of the project going forward. All right. So again, Python suite for cryptography. I wanted to be able to, encrypt plain text, decrypt ciphertext, brute force certain ciphers, one file input and output, text input and output, and then one-liners. In this main ciphers I'm going to have is the Caesar cipher, Visionaire, multiplicative reverse, and then base 64. Base 64 isn't a cipher, it's an encoding, but it still is pretty prominent within the cryptography world. Once we have these 5 ciphers done, that'll be kind of be considered like the version 1, right? And these will be like just added on as the project goes on, right? So I guess we can actually read the Caesar cipher one because that's the one we're going to be doing today. I have done Caesar cipher in Java and Python in the past, so I'm going to take my old code today and kind of reformat it so that way we can, so that way we can, I guess, have it be more prominent to the Codex project because it's an older piece of code. It's not that good, and it needs to look cool in order for it to be part of the, I guess, the rest of the suite. So let's go down repositories, and if we scroll like all the way, yeah. So Python Caesar cipher. So I mean, it has the functionality we need. So I think I might just take this code and kind of just, reformat it, I guess, and make it more prominent to our suite. So we're going to copy that. Awesome. So again, Caesar cipher. I've covered this like twice in the past, 3 times probably. So I'm assuming you guys should be familiar with it. If you guys aren't, I'll just basically tell you it's a cipher that shifts each letter within like a certain set of plain text by a certain amount. So if we have something like hello world, if we had a shift of 1, it would shift each of these letters 1 place down the alphabet. So H would be I because it's H-I, J, K, L, M, N, O, P, or whatever. So F comes after E, so it would be shifted to F, and etc. It's pretty simple, and you can shift it in between from, I guess, technically an infinite amount of numbers, but there's only 26 possible placements, which makes it easy to brute force. If you guys are confused, just Google Caesar cipher or take my cryptography course, which is on my website. It's completely free. It just teaches you all the basics of cryptography, and you get a certificate, so it's pretty cool. So I guess we actually need to get started with this whole thing. Let me go ahead and open up PowerShell. I'm gonna use Kali to do this. And I have clear. Software is an alias to take me to my code file. So we're going to cd into our Codex project. Nope. We're going to cd into Python and then Codex. Yeah, there you go. And then we are going to make a directory in here. And this directory is going to be for our packages. So we're going to do ciphers. There you go. So if we change directories into ciphers, we need to touch a... How do you make the package again? Is it like double underscore init.py or is it just init.py? Python package init.py. I can't believe I forgot this, but I haven't coded in a break. Okay, yeah, it's double underscore. Cool. Init.py. Is it like that? I don't think that's right. I think it's like, yeah, there you go. And that init.py file just lets your code know that that folder is a package that we're going to be using. So in our package folder, I guess we can kind of just, I'm going to do cd out of here. I'm going to make another directory for resources and cd into our resources, and then git clone this old repository. Whoops. There you go. Yeah, so now basically we're just going to be taking this old code, making it better, and that's going to be it for today. But yeah, I'm going to also kind of make like devlog type episodes. So this is just like the stream where we're kind of just coding it and stuff. But the actual yeah, but I'm gonna make actual devlogs where you can kind of see the code. I mean, I guess this being condensed down to what we actually did, and they'll be kind of like almost like if you ever seen any devlogs by game developers, it's going to be kind of like that, but like for cybersecurity. It's going to be pretty cool, I think. But yeah, so Codex Ciphers. Do we have anything here? No, we need to touch our Caesar text cipher.py. And I will drop the link to the Codex Project. If you guys want to contribute to the project or anything, it's completely open source. I just made it public. Do what you want with it. There you go. It's in the chat. So I can close this. We don't need that. I'll keep that open for now. And if this text is too small, let me know. I'll make it bigger. Yeah, so resources and ciphers. So this is the file we're going to be working with. And because I want this to be like cross-platform, I want to add a shebang in here even though I'm on Windows. So bin, what is it, user bin Python? I think that's right. All right, cool. So we have this getting started, and then we need to take our resources and our Caesar cipher.py. Awesome. So I guess this package needs to be able to be imported into our main file. So aside from all these folders, we're going to need a main.py in our so we can do cd out of here. Yeah, there you go. So we can touch a main.py, and that main.py is going to be our actual Python file. So I guess we'll just see how much progress we can get done today, and yeah, we'll see where it goes from here. Dope. User bin Python. So it's going to be a Caesar Cipher package for the Codex Project. I can't really use the Codex Project as an acronym because it's TCP, and that's already something pretty prominent in coding. There you go. Cool. So Caesar Cipher package for the Codex Project, and of course, it's going to be created by I guess Cosmo. Dope. So I guess we should check out how this Caesar cipher works, or how we did it last time. CD out of here. Oh no, CD into resources, and then Python 3. What's this file called? Oh, I had to CD into here first, and then Python 3 Caesar cipher.py. So you can enter a file name, just already an encrypted Caesar.txt. You can do encrypt shift over 5. All right, cool. So the thing is with this, it only takes in file input. I want to have it where we can incorporate whether we want like file input or like a text input. I guess we can have it detect if it ends with like txt type of thing, unless if there's a message that ends with .txt. So we'll have to figure that out. So def main. Cool. So how did we? So yeah, we have a Caesar main. That's a better idea. I'm going to do Caesar main because when did I code this? This had to be early January, probably. Huh. So we immediately ask for a file name, and then we see if the file is even existing in the first place. Okay. So I guess what we should do is in like the main pie, they'll ask the user if they want. Hi. This is going to be hard, dude. I'm going to take out the Caesar.md file here so we have like a good reference. Because yeah, this is the Python equation that you need to use in order to encrypt text and decrypt text. Again, the README and all the README stuff is on the GitHub, so you can just read through that if you guys are kind of lost. And I'll probably explain it once I make like the shorter versions of these and do like those types of things. Okay. So, because this is a package, we need to have the main.py kind of take from the functions within this file. So we're going to need some sort of def encrypt Caesar. No, that's right. I have a translate. Translate Caesar. So what I did in my old one is that I decided that instead of making it a separate encryption process and decryption process in like two different functions, because they're like the same thing just with different equations, I just put it in the same function. So yeah, I have there's a fly mirror. I have this translating function. Where is it? Yeah, translator. And this will encrypt and decrypt at the same time, depending on what option they chose. So I don't know how much I want to. I guess I should incorporate that because it's a little bit more effective. And all right, so let's kind of start developing our newer version. We're going to need a banner, and the banner will be equal So let's go here. There's this website. I think this is it. Yeah, right here. All right, so Caesar Cipher. Do I want a tag in between that? Yes, I do. That looks cool. All right, so we're going to use this as the banner. All right, so we can just kind of paste that in here. All right, so we're going to have to use like escape sequences and stuff to make that work. Or we can use a docstring. Cool. I think that should be fine. All right, let me print out. All right, we're just commenting all of this out. And we're just going to print banner. Okay. Does that look right? Almost. It's like, is that how it's supposed to look? Yeah, no, there's like a shift right here. This top part should be like back by one place, I think. Let me try that. Was it Control F5 or something? How do you run this? Control F5, yeah. All right, so that top part, and now the bottom is misaligned as well. So let's try that. All right, there you go. I think that's it. Is that right? Say. I think, yeah, no, there's still something off here. I think the escape sequences I might have to do it. Let me try this. Oh my gosh. Yeah, this is not working out. All right, we'll focus on the banner later. It's not that important right now. Cool. So the functions are going to have to go on top of the banner so we can keep everything organized. So, except for the Caesar main. Caesar main can go in here. So def Caesar main. And in here, we're going to actually have the main. So I guess, I don't know how I want to do this. How can we get, like, argument, what's it called? Argument parsing in Python? I think I kind of figured a way how to do that, but I never really remembered it. Let me see. We can close this. So argument parsing in Python. Yeah, I heard of argparse, but I know there's another way to do it. watch this video, and we're going to mute him because I'm not trying to. There you go. Awesome. So we just need the. All right. Yep. Stop talking. Yeah, I don't feel like watching this whole video. I just need like some documentation or something. I think it has some notes I wrote a while back about argument parsing. Let me see if I can find those. Yeah, so I guess you'll just have to give me a second while I look for this, because yeah, hopefully this project should be pretty cool. It's been, I guess, in the works, quote unquote, for like a year, but I figured it would be pretty cool to actually try and start. All right, yeah, I found it. So I'm gonna just take a picture of this with my iPad, and then we'll just try to incorporate all of this. There you go. Awesome. Put it on the floor, and we're back to action. There we go, my photos. Cool. So I guess we can have our imports, and we're going to have to import sys, and we're going to import our get opt. Cool. So what I'm seeing is that okay, so there's different arguments. Got it. Okay, I remember how to do this now. Yeah, I had to go through my notes, and my notes are on my other computer. So, yeah. Anyways, so we're going to have our banner here for the Caesar Cipher main, and then we're actually going to have to get some arguments. So let's go ahead and kind of just play around with this. I'm going to have... So let's see if we can have some, I guess, I don't know, testing or something with this. So we can print sys.arg v, and then we can do 0, and then print sys.arg v1. So if we let's see, cd out of here, cd into ciphers, and if we python 3 or Caesar cipher.py, and we add like word after it, our argv1 is Caesar, or argv0 is the Caesar cipher file, and argv1 is word. Okay. So now we can also get arguments, is what I'm seeing. So we can have our options and our args is equal to get opt, that get opt, and then we have our sys.arg v. Full credit to Neuro9, by the way. That's where I got these notes from. So yeah, definitely check this channel out. We're going to do F, M. So F is going to be our first like tack, and then M is going to be our second like argument, I guess. And then we can also have those definition. So file name and message. Okay. And then that's right. So you can do if, or you can do for opt arg in is equal, or our file name variable is going to be equal to an argument. And then we have if our opt is equal to attack m, then we can say a message variable is equal to our arg. So that's how argument parsing is going to work in our code. There you go. So I'll just do argument. Well, you won't be able to see that comment in there. So we'll do argument parsing. There you go. So this is going to be a resource that we're going to use. I'm going to just have this be like right here. Yeah, there. I'm just going to have it paste right here so that way we can always come back to this section. So basically, these allow us to get certain arguments that we run in our like Python code. Okay, so I get it now. So what we're going to need to do is have all right, so let's make a function. We're going to call this parser. So we'll do def parser. And this will basically parse all arguments. Cool. So what we're going to need is basically kind of incorporate what we got going on here. So I'm going to copy this line we have here. I'm pretty sure in Visual you can just copy the line like that. Yeah, there you go. So let's have this. So ops args equal to get opt. So everything past 1. Cool. So instead of file name, we're going to have, what arguments are we going to have, right? So we need to make our arguments that we're going to actually need. So no arguments. So there you go. So I guess tag F can be for a file. Tag F is a file. File input and output, right? Oh, we can have tag IF, right? Tag. So we'll have tag I for input type. So input. So you can do tag I file or tag I text as like what comes after it. Okay. I think that should be fine. And then we can have a tag O for output type, right? So the output type. And then our options would be file and then text. So we can have an input type and we can have our file text. Okay. Now I'm also thinking like if we have a default interface, also kind of like Metasploit or some other shell codes, like it's also there as a viable option for people who aren't familiar with one-liners. because I feel like that would be very helpful for them on their part. Okay. So what other arguments are we going to have in here? TAC, E for encrypt, TAC D for decrypt, TAC B for brute force. And I think with the brute forcing, you should be able to add a range, right? So, because if there's 26 possible keys in the Caesar cipher, right? You can either brute force all 26, or you can brute force just a certain set, like the first 10 keys, or the 15th to the 26th key. So I think that would be pretty cool if we could get like a range imported in here. So I'll add that as like a note. And I'm just letting range, let's call it incorporate range into TAC B. So we can make it a separate one if we wanted to, like a TAC R for range. I guess that would be easier. Or a TAC R. There you go. So we'll worry about that once we get there. But I guess we can have an input type and output type, the option to encrypt, decrypt, or brute force. Okay. And we're going to have to fix that banner because that's ugly as heck. So our Caesar main file, this is going to print our banner, and then I guess we'll have it as an F string banner, and then we're going to have a \n, \n. There you go. So we'll have this display banner. Then we have the actual so displays banner, it'll print the banner, and then I guess, how do I want to do this, right? So we should have it check for arguments, right? So if there are no arguments, it will run as is, and if there are arguments, then it will incorporate the arguments into the file. Okay. So this is annoying. So let me actually incorporate these arguments as well. So we'll have a I, we'll have an O. Where are the other ones? E, DB, E, colon, D, colon, B. There you go. So those are the arguments we're going to be adding. Do I add a colon after the B? I do, okay. Cool. So that's going to be input. This is going to be output. This is going to be, I don't like how inconsistent my quotes are. So inputs, outputs, what's it going to be here? Encrypt, and then we're going to have a decrypt, and then a brute force. There you go. All right. So now that those arguments are in place, we can actually have them detect. So if I guess we'll just stick with the opt and arg stuff. So we'll do a for loop. So for the opt and arg in our ops, we can actually start incorporating the detection. So if our opt is equal to tech f, can I have an or like or tech file name, or tech oh yeah, we're not having the tech f in here. Oh my gosh, I just realized. So for our input, we're going to all right, so if we want both text and file input, that's fine. If the tech f value says, I think we should make it different. I'll have like a tech if maybe, or how about a tech t for tech? So tech I for, so I don't know if we should have how the input and output should work, right? I would like for it to have both text and input. What do you call it? Text and input. What's what I'm looking for? Oh, I'm mixing it. Text and file input. That's what I meant. So I want text and file input and text and file output as both options. Both of them as options. So what we can do is have a tech f I'm thinking. So when you run the script, you want to have it read the file and output it on the terminal screen. All right, so we'll have different input types. We'll input file, so if or input file. So input file, this will be input text, and then this will be output file, and this will be output text. There you go. So input text, and then here we can input a file. Here we can have an output in a file format and an output as text. There you go. Okay. And then we have the actual options in here to encrypt, decrypt, and brute force. So we have input and output and our actual encryption options or ciphering options. Cool. That's good. That's good. Why is this tripping? Oh, I never finished this. Okay. So if our opt is equal to, oh, that means I have to redo this. Okay. So we're going to need an IF. We're going to need an IT. We're going to need an OF. And we're going to need an OT. And then, so cool. So this will be input file. And then we're going to need a input text. And then we'll have a output file. And then finally we'll have an output text. All right, that's pretty dope. There you go. Oh, that's a large line, but it's fine. Cool. And then that's all good. That's all good. Perfect. So if our opt is IF, or we'll just call it input file, then we will assign we'll call this file input option or input type. Input type will be equal to the argument. Oh no, so if it's an input file, we can have our file name. File name will be equal to the argument. Okay. And if our opt is equal, is equal to a tag IT, or is going to be equal to tag input text, what are we going to put in here? I guess our cipher text. So cipher text will be equal to arg, and we can say, well, file name isn't specific enough. I guess it should be cipher file. There you go, cipher file and cipher text. So if our opt is equal, is equal to a tag. Oh, it's not tag T, it's tag IT. This is going to be tag OF, or, oh, that's not right. Or the opt is equal to that, or the opt is equal to that, or the opt is equal to our tag output file. There you go. So our output file is going to be our so we can do plain, we'll call it plain file. And so plain file is going to be equal to our argument. If our opt is equal to tag OT, or our opt is going to be equal to our tag, what's this going to be, option? Output text. There you go. Output text. We can save this as plain text is equal to arg. And then we're all going to have to incorporate this into some sort of function or something. And I don't even know if this is going to be included in a parser function. I might just... Oh, we can return a list and then give each list or each index of each item in the list represent one of the arguments. Because how many arguments do we have? 1, 2, 3, 4, 7? Yeah, we have 7. So that shouldn't be too hard to keep track of. I might do something like that. So our plain text would be equal to argument. And then, so this is going to be ciphering options. It's going to be, all right, Shrimp, I'll see you in a bit. What's this going to be? Ciphering options. This is going to be our input options. And then this is going to be our output options. And then ciphering options. Cool. So our ciphering options are the encryption process, the decryption process, and the brute forcing process. Those are the three I'm going to have in here. So we're going to have an opt be equal to our tag E, which is going to be for encryption. And then, or our opt is going to be equal to our tag encrypt. Because that's what we put, right? Encrypt, not encryption, just to make sure. Yeah. So tag encrypt and then our, I guess encryption will be equal to true. Did I already make encryption something? Oh, I made equal. Whoops. Encryption will be equal to true. Then we can do if our opt is equal to, whoops, our tech O or, whoops, or our opt is equal to tech. Why did I put O? I think it's tech D. Yeah, tech D. And then it's going to be our decrypt. Whew. All right, so this is going to be our decryption option. So we can just do decrypt is equal to true. And then, how do you do this? Shift enter, right? Control shift. Yeah, there you go. And then our if opt is equal to tag B, we can actually brute force this thing, right? So tag B or opt is double equal to tag brute force. And then our brute force is going to be equal to true. And that should be all the arguments done. There you go. Finally. So, yeah, all right, awesome. We have those arguments done. And now they're all assigned to variables that we can apply into the functions and processes we're going to be incorporating. Whew, okay, that was a lot of work. Dope. So here is our main code. So we display the banner. Now I guess we need to check if we have any arguments. So if we need to checks for arguments. And I guess we're going to have to incorporate something similar to this in our main file for the codex. All right, so checks for arguments. This will be if. I guess we need to see if sys.argv 1 exists. How do you check if that exists? So if sys.argv with the index of 1 is equal to true, I guess, would that work? Can we just print? We'll try this. Arg exists. Okay, so let's actually whip out this. Oh, we don't call the main function. So down here we can just call Caesar main. Oh, if underscore name equals main, then there you go. All right, now let's run this. Oh, we can just use a try and accept. So we'll try this, and if we get an index error, there's no arguments. That's perfect. All right, so try sys.argv equals true. Oh, we don't need to do that. We can just try to set argv. I guess that's fine. And accept. How do we do this? So not just any except in is index error, right? Yeah. Index error. Then we can say, okay, so if we get an index error, that means there's no arguments, which means we can just use a graphical interface. So I guess we can say, not graphical interface, but like the non-one-liner, right? The command line interface, CLI. So we can have a CLI. All right, I want to figure out how I'm going to, I guess we can have, so if we don't have any arguments, then we can set an arguments variable to false. And then we'll just use that. So arguments, so our arguments variable will be false because there are no arguments. So I think it's else, right? Else you can use to see if it ran successfully. And it's funny, I taught Python and I actually forgot this. Let me go on my GitHub and let me see if I can find Introduction to Python 3. But yeah, if you guys want to check out my Python course, it's on my website, which is linked in the description. It's completely free and you get a certificate at the end. Yeah, it's pretty cool. All right, when did I talk about try and accept? I guess I can show you guys this. I don't really care. So, file exception handling. There you go. That's module 9. All right, module 9. And else. What does the else do? Else runs if no errors occur. There you go. That's what I thought. So if no errors occur, then actually I can close this. So if no errors occur, then we can have arguments equal to true. So if we run this, I'm going to, let's print arguments at the end of here. So print arguments. Let's see if it's true or false. So Control F5. So false, because we don't have any arguments. And if we run it through here with Word, it's going to be true. Yes, sir. There you go. All right. There you go. So if it's true, because we have an argument there. All right. Dope. Okay. So if we have no arguments, we can have a simple like a simple CLI for users. And I guess we should make like a CLI function, I guess. All right, we'll put this right here. Def CLI. Yeah, CLI. And we're going to take in we'll call it argument check. There you go. All right, that's actually pretty dope. I can't lie. All right, so if for command line interface, I'll put that above here so you guys know what that means. Command line interface. All right, so in here, we need to make sure that we can have, I guess we'll check first. So if the argument check is equal to true, whoa, there's a fly in my room, dude. I don't know where it went, but got me. All right. I don't want to like hit it and clap because that's going to be loud on your end. But yeah, all right, so this should be pretty dope. Oops. All right, cool. So, how do I do this? So if argument check is equal to true, it means we have arguments. So we can run like the parser and stuff, I guess. So parser. So this parser, we need to return these values so we can use them. So return so if I want to return, because the thing is, if I return, it's going to end the function. So I can't return each of these within these if statements, because if someone adds multiple arguments, we won't be able to read them. So instead, I guess we need to give all these variables a definition, like initialize them, and then have these just be the reinitialization, like redefine them. So the question is, should I have these be, all right, you know what? All right, so Cipher text, or Cipher file equals none. Nope, just none. Cipher text equals none. No, why does it keep doing that? I'm just gonna copy this, dude. All right, plain file equals none. Plain text equals none. Encryption. Oops. Encryption equals none. Decryption also will equal none. And then our brute force option will still, again, equal none. So what we're going to do is take these, comment them out, and argument variables. There you go. And we can move these to the end there. Cool. I guess if I wanted to, I can go more in depth with comments and kind of explain what each of these do. But we'll worry about that eventually. So now let's return our argument list. Well, I guess I can make it a tuple because it's not going to be changed. Argument tuple is equal to Cipher file, Cipher text, plain file, plain text, encryption, decryption, and brute. All right, there you go. So this will return the argument. Well, we don't have to return anything if wait, if the argument, no, the argument tuple would have the values of none. We need to update it. So we need to, this argument tuple would have to be returned in here. So return argument tuple. You don't have to give it a value, but we can just, yeah, return that. Awesome. So now, so if it's true, we'll run the parser, and the parser will get all of these variables for us and return it. So I guess we need to say arguments is equal to parser. Oh no, we have an argument here. Arguments, I don't know, exist is equal to true. Arguments exist is equal to false. Print arguments exist. There you go. So this will check if they're true, and then else, because otherwise the arguments don't exist. So now this comes to the point where we have to actually design the CLI, right? So I guess the CLI is more of the main than, because this can be like the Caesar initial, right? Because the banner can be displayed in the CLI. Then here we can check for arguments. But what do we do after that? So I guess we need to see what options they chose. So if they did the argument parser, then we can just encrypt I guess if we have, all right, so let's make our actual function where we can do the processes, right? We can encrypt, decrypt, translate, or I'm sorry, decrypt, oh my gosh, I cannot speak English. Encrypt, decrypt, and brute force, right? Those are the first things we need to do. So in our translate function, all right, so we need to encrypt. I guess we can make a function, right, for encryption. We'll make them separate. So encrypts text. So def encryption or in def encrypt Caesar. Because we're going to have to make some modifications to this once we apply it to our main code file or our code base. So def encrypt Caesar. Oh, this is going to be hard, dude. So what do we need to encrypt? We need content, whether it's file, text, or whatever. Well, if we're encrypting, we need plain text. So let's say plain content. And then whether it's plain text or a file that contains plain text. And then our encrypt Caesar. And then we need to, oh, we need a shift. Oh, we need like a key. Key equals none. Okay, where are we going to put that key? So plain text, we'll put the key right here. So tech K equals the key. I forgot about the key. All right. It shouldn't be that big of a deal though. We can just put a K colon here. And then right before the encrypt, we can do key. So key there. And that. Awesome. All right. Get some water. Cool. All right, let's see what else we can get working on here. Why is the part? Oh, it's because I have this. So in order to encrypt something, we need the contents and we need the key. We can call this encryption key. There you go. So when we're encrypting our Caesar, we can just do our encryption process. Now, let me open up our old file. And how did we encrypt? So we set, we need an output option. So we'll say output, type. All right, so I guess we're going to make an output variable, and it's going to be an empty string. And we'll just basically add all of our context to the string. Now, if the output type is text, then we'll just print it out. And if the output type is a file, then we will write it to a file. All right, cool. Cool. All right, let me think about this. So this is the output variable. Output variable. All right, so now what we need to do is actually encrypt. So we need to do for character in the plain content. If our character, oh, that's right. So Caesar Cipher can't detect symbols, so we're going to need, so we'll say symbols that, hey, welcome back. Symbols that all right, so we need symbols that can't be detected. Let me give you guys an update in a second, in case if you guys are getting a little lost of what I'm doing. All right, so symbols that can't be not detected, can't be processed through the cipher. There you go. All right, dope. So let me make this a bigger screen. All right, awesome. So this is what we're doing so far. All right. We're making, like, as you guys know, a cryptography suite. So we're going to have It's going to be like a shell script if you ever use like Metasploit or something. It's going to be like that, but for cryptography, right? So we're going to have a bunch of different ciphers. We're going to have, where's the README for our roadmap? This one, yes. So we're going to have the Caesar cipher, Visionaire, multiplicative, reverse, base 64, XOR, phonetic, binary, octal, hex, and Morse. Different ciphers like that. That's basically what this is going to be, right? Right now, we're working on the Caesar cipher.py file, and this is the Caesar cipher.py is in the ciphers folder with an init.py file within it, which means it's a package, right? So what we're coding here is basically a Caesar cipher package that our main codex file is going to use. Okay. Right now, we need to have our code to make it as easy for the user as possible, right? So I'm not only going to have one-liners, but we're also going to have a CLI or a command line interface. And this command line interface is going to be something that the user can interact with. So again, when you're, interacting with the code, you can either do a one-liner, just have it be like, codex.py, tech, whatever, tech if for your input file, tech ot to have it be printed out on the terminal, and then like tech e to encrypt the file, and then tech k for your key. So you can just do that in one line, or you can interact with it, and it will ask you for your key. It will ask you for your file, that type of thing. So that's kind of what I'm doing right now. And we just got the argument parsing to work. So if we run this, okay, let me comment this out. So if I show you guys this Caesar main indented block, there you go. All right. Now, if I show you guys, oh my gosh. Yeah. So if we just run the Python file as Caesar cipher tech.py, it's going to say false because we didn't add any arguments. If we do this and say hello, it's going to say true because we did add an argument to it. So that argument detection is going to allow us to detect whether or not they're going to be using one-liners. So if there is an argument, which is true, then we can just incorporate one-liners into whatever they're typing. Otherwise, we're just going to have it be like an interface that they can interact with, kind of like a Metasploit type deal. So hopefully that kind of clarifies what we're doing right now. And if you guys have any questions, just let me know. All right, so what we need to do is uncomment this. So how do we encrypt? So if our character is in our symbols file, which is right there, then we can just have our output plus equals. So what is this text variable from? Text plus equals letter. Oh, so text and output text. What did I do here? Oh, so an extra character is sometimes added. That's all right. So we just remove it. Okay. Which is why we have a separate text and output. So I guess we can do that. I'm gonna just use single quotes throughout this thing because I want to try to keep it as consistent as possible. You know what they say, clean code is better code. So yeah, we're going to be sticking with single quotes. I got like onto that, except for doctrines, of course. But okay. All right, let me figure out what I need to do here. So we can just add it to the output and then delete the last character from the output. I don't know why I did all that extra stuff in my old code. So output plus equals the character. Okay. And then we'll say elif the letter dot is upper. Then we can go ahead and have the output be plus equal to, and we will literally just copy this line. Oh no, that's decryption. Whoa, that would have been bad. Encryption, yeah, right there. If you guys, this is just the equation to encrypt, nothing more. I do talk about it in my README file. So else we can do output plus. So instead of letter, we need to do character, and then instead of shift, we need a key. Wait, what do we call this? Encryption key? Encryption key. Encryption key. Oh, I made myself. Oh, nice. That sounds good, dude. Didn't press enter, came a little later. That's all good. I don't know if you heard me explain what we're doing, but if you're a little lost, just let me know and I can tell you what we're doing. I may make myself some food later. I don't know how long I'm going to stream. I'm thinking 2 hours might be good. I might do 3. Depends on how I'm feeling after the 2 hour mark. And once this is finished, I'll push it to the GitHub link I dropped in the chat. So if you guys want to, I don't know, fork it and do some of your own creative stuff on it, you can. But again, this isn't going to be done until like, I want to finish this by December is what I'm thinking. We're making some pretty good progress right now, but that's right now. There's a lot of ciphers I want to do. So I'm thinking finishing it by December would be pretty cool. But yeah, what else are we doing? Okay, so that should be the encryption process done, right? And then it removes a character from the code. So let's shift tab this and drop that down one line. So this is the actual encryption process right here. And then this will remove extra character. There you go. Oh, you know what we could do is just match the length and see if any extra characters were added. Huh. All right, I'm a little lazy right now, so we'll do that like tomorrow. But like, let me add that as a note so I don't forget it. Match lengths of code to match lengths of, I guess, ciphertext to see if any extra I did a backslash, did I not? Okay. To see if extra characters exist. All right, there you go. A little note to myself. Okay, now we need to have our text length be equal to the output for number and range of our text length, our output text can plus equal our output. Oh, I see why I did that. Okay, so I wasn't so dumb. I guess, I mean, like, I'm not really sure on how I want to do this. Oh, whoops. I don't know what that did. I guess with output, and then we can do an output text and have that be equal here. And then our output text plus equals our output num. That should remove the character. Okay. And that should be the encryption process done. So def season. So here's the problem, right? This is, I mean, this should work, but the problem is like, I'm trying to figure out how to explain this to you guys. The problem is the one-liners and CLI incorporation. So we're able to get all of the arguments that we parse in, and we're able to check if there are any arguments that we added to our file. So that's fine. The problem is when we're encrypting, we need to make it applicable to both one-liners and our CLI. So our plain text content, oh yes, we need to have our output type. So our plain content is going to be the string version of our text, of our plain text. That's right. So our plain content is the string version of our plain text. Our encryption key is the key we need to use to encrypt this set of plain content. And our output type is how we're going to output it. So I guess we can do like a if output type is equal to how do we want to do the output type? Like, how do we want to know if our user is, all right, I'm kind of confused. Not confused, I'm kind of, yeah, you guys can see how much I'm stuck a little bit. I just don't know how I want to have this output type, because the two output types are a file or text. How can we detect if the user, wait, we have, okay, we can check if each file is none. There you go. Okay, so if our Cipher file, so for, okay, I think I know how to do this. So we need to be able to see, all right, so if, let's say they encrypt the file with an input of if. That means if has a value of the file name. So if is assigned to cipher file, and cipher file right here. So if cipher file is none, so if our cipher file is equal to none, that means they want text output, right? So then we can just print output. And oh, you know what we don't need? Oh, we can get rid of our text variables because we can just have it print to the screen by default, and you can just have the option to save. Okay, hold up. So a cipher file is an option, but we don't need to worry about a cipher text. Let me not delete it in case if I mess this whole thing up. So we don't need cipher file so cipher file and plain file are the only variables we need now. We can get rid of this, and we can get rid of this. And then that means we don't need an IT anymore, and we don't need an OT anymore. In fact, we can just make it tag I and tag O. Oh, this is awesome, dude. All right, so tag O. All right, this is good. This is good. We're making progress. Input text, we can delete this. And then key. All right. So our key is, did we incorporate our key into here? No, we didn't. If our opt is equal to attack K, or our opt is equal to tech key, then we can have our key be equal to the arg. And this should be going above the encryption, so that way we can stay in order. There you go. Cool. So right in front of encryption. Yes, we can delete this now. We can delete this now. And then you can put a key in here. Awesome. All right, there you go. So I guess now in our encryption, do we have the key equals none? All right, cool. So if our cipher file is equal to none, we'll print it out. Otherwise, else, then we can just do a with open our cipher. Why is the cipher file now? Cipher file should still exist. Why is this yellow? Cipher file is not defined. I defined it right here. Cipher file. All right, we'll figure that out in a little bit. So with open our cipher file in, let's say, write mode as f, then we can do an f.write the output. Oh, we need to print the output text. And we need to make this the output text. There you go. And then this can just be the area of where we, there you go, output content. Hello, Eli T. What's up? What's up? Yeah. All right. So I guess the encryption process is done, right? Oh, we need to have it the output type, right? Well, do we need an output type? Because if the ciphertext is none, we'll just print it to the screen. Otherwise, we'll open the cipher file because the cipher file is attack I and the argument the name of the file. So the cipher file is the name of the file. So we'll open it as F and then write to the file. I think. So we don't need an output type, hopefully. Hopefully that's not a mistake. All right. All right, I think that's it for the encryption. So let's say we ran this, right? It would see whether the arguments exist or not. So if the arguments exist, we can, I guess, towards here, we can just run the CLI with the argument check. So we can just do arguments exist. There you go. So it would run the CLI and then it would print the banner. So if it's true, it would run the parser. And then, all right, so now I just need to figure out how we're going to actually get our, I guess, what do you call it? Get the syntax working, right? So if I ran the file and I did like attack I for our file, attack O for our output file, and then the attack E to encrypt, what would happen, right? It would recognize those. So it would run the Caesar main. It would run our command line interface. It would print the banner and it would check if we have arguments. If we have arguments, it would run the parser. And the parser would just get the variables to, oh, you know what we could do? No, that's too much work. No, never mind. It will run the parser and it will get this set of variables. So then, so instead of setting encryption to true, oh, okay. So run the parser. So okay. How are we going to do this? So if, which one is this? 0, 1, 2, 3. So if arguments 3 is equal to true, we're going to run the encrypt Caesar. And what goes into the encrypt Caesar function? Plain content and encryption key. All right, so we're going to need a read file function. Reads. No, we don't. You can read files in like one line. We're not going to do that. Do we? We might actually need that. I'm not sure. We're also going to need the general package to make later on that applies to all these files so we can shorten the length of our code and stuff. Yeah, there's a lot of work that's going to come into making this, I guess, work. My brain's starting to hurt a little bit. I can't really think straight. I need to... So what's next, right? If that's running the... Oh, that's right. We need to get the arguments in. So we need to... Plain content. How do we get the plain text? So if the... So let's say we're doing encryption, right? Oh, this is going to be difficult. All right, so we need to figure out whether or not a file exists, or if they inputted a file, right? So check for file input. So if the argument for Cipher file or plain file, what's the difference here? Oh, they're just so plain file is the output file, that's right. I'm going to do some variable renaming because that might get confusing. And is the text big enough for you guys? Is it hard to see at all? I can make it bigger. I'm going to make it a little bit bigger, just in case. I'll do like 26. All right, that might be better for you guys. Cool. So, all right. So we need to get the plain content. How do we do that? So if, oh, it's big enough for you? Oh, okay. I'll probably keep it like this for now, and if it's too annoying, then I'll move it. So if the arguments position, so if we have an input file, right? So position 0 is equal, what do we assign that variable? Oh, it's not equal to none, right? So if it's not equal to none, that means a file exists. So if it's not equal to none, file exists. So that means we need to read file, and that will be equal to open arguments 0 in dot read, like that. I think that's right. Okay, so if it's not equal to none, there's a file name there. We'll have the read version of the file equal to the arguments, and you read it, and that's going to be what you input into here. So the file contents in here, it's either going to be, where's the encryption? Let me put that there. Okay. So the plain content is going to be argument position 0. The problem is we need to figure out if there's a file there. So we figure out there's a file. So now we can say, so if they put a file there, we need to either encrypt, decrypt, or brute force, right? So if arguments, you know what? I'll just take, so if there's a file there, we can encrypt it with the read file and the encryption key. And then, so we can do what's position 0, 1, 2, and then arguments, arguments, oh, we need a check. So after we assign all these variables, don't we need to check if they exist, right? So let's say someone is running a one-liner and they use attack, I don't know, like attack I for their input file, and they don't incorporate attack K. We need to make sure that attack K exists. This is going to be way more hard than I anticipated, but it's fine. Encrypt, Caesar, read file, and then arguments position 2, I believe. 0, 1, 2, and that's the key. So that should encrypt it. Can we actually run this? So if we do like, oh, I think we do need ciphertext, because you don't always need to import it as a file. Oh my gosh. Remember earlier when I got all excited about how we may not need to, well, we don't need an output text. So we don't need an output text. We're fine on that, because the output text is just default. However, we still need an input text or an input file, because we need input regardless. Because it's a one-liner. All right, so we'll reimburse or whatever, revive this line right here. So this is tech IT. This is going to be tech IF. All right, and then cipher file. Oh, that means all numbers are going to shift over. That's fine. Cipher file, cipher text. All right, and then in here we have attack IF, and then attack IT. All right, and then in here, input file, we're going to need input text. And if you guys are confused or have any questions or anything, just drop them in the chat and I'll explain. So we get the arguments. This is attack IT, so we get that, okay. And then this is now position 1. So argument 0 is still the cipher file, so that's fine. And argument 2 is no longer the key. Argument 0, 1, 2, 3 is the key. All right, so argument 3. And what was argument 3 before? So if our encryption, so 0, 1, 2, 3, 4. So this is going to be if argument 4 is true. So this is going to be encryption, so we don't get confused. Encryption option. Cool. So if they have arguments, we're going to basically do all this, right? So if they have arguments, if they have a file, then if they have a file option, then we're going to encrypt with the file if they want to encrypt. And then we're going to have to incorporate decrypt and stuff after here. So you do incorporate other cipher options here. All right. Cool. All right. Now, else, this is going to be if they want to use the CLI instead. So else, so if they don't have arguments, we can say like choose an option, right? So we'll say print, so we'll display options. Display options. So we can print okay. This fly is still in my room, dude. You just see me like swatting and stuff as I'm trying to cut it. All right, so we need to print the options that we have. So we can say options, and then we can do a \n. We'll have a \t to tab, and this will be a 1, and we can say encrypt, a new line, and then a tab, and then a 2 to decrypt, a new line, and a tab. Whoops. And this is going to be option 3, which is to okay. Oh yeah, and brute force. So that's fine, and then option can be equal to an input, where you can say, oh, I might like, should we put colors in here? How do you do colors in Python? colors, Python color. I don't know, terminal. Bring colors in Python terminal. Okay, so we can have colors in here. I feel like that would make the project a little bit better, you know? I think we should go for it. Not right now, but eventually adding color would be kind of a cool aspect. All right. So we'll keep that in mind in the future. I'll put that at the top here, like add colors. I feel like that'd be pretty dope if we added colors. All right, so when it comes to, all right, so I need a variable here. We're going to call this, I guess, path. I don't really know what else I would call it. And this is just going to be, so we're going to need to import OS. How do you get the username with OS? Oh, it's like different for like each operating system and stuff. So get, we'll just do generate path. And here we can do def. Let's call it path. Path. And here we'll return a f string of their username, and it'll be at Codex. There you go. So username is going to be equal to Python get username. Is there a portable way to get the username? The get pass module. Okay, so that works in. All right, I guess we'll just try it in PowerShell. Let's do a Python 3. Oh, so get pass that user gets Blue Cosmo. Okay, that's cool. Yeah, so we'll just incorporate that into here. Import get pass. We'll move that into our import area. So we don't need OS. I thought we would need OS, but we don't. So we can just use the get pass, and then the username. So get pass get user is equal to this. So I guess we don't even need that. We can just do path is equal to that. All right, awesome. So we can get rid of the path variable we have here. We don't need that. Awesome. So when we're doing our CLI down here, we can have our input be an F string, and then we can have our path, and then we can just say option. Should there be a space after in the path? We're done with this. We can close that. Yeah, we'll have a space right there. So we can just not have to worry about spaces. So option, and then we'll have the tilde to represent input, and it will be like that. Like that. That should be good. Is that better? No, I like that. All right. Or I can add the tilde beforehand to show that it's input. Yeah, there you go. All right, that's one. So it will show that we need an option. So, and all we'll have to do is if option is equal to the string version of 1, then we can do the encrypt Caesar, and our plain content is going to be our arguments with all right, so arguments parser. Whoops. There you go. So it will be our arguments, and then we need to get the text version. So, well, no, if they're not, no, so it will be equal to, all right, so yeah, we'll say plain text. Is that a variable we used already? Yeah, it is. I'll do plain input. Plain input is equal to input. Oh, but now, oh my gosh, dude. See, with a CLI, the problem we're going to have is we don't know. They had to choose whether they want a file input or a text input. Okay. So we'll let them. Oh, instead of numbers, we can just use like something to represent the argument parsing that would be there to begin with. Okay, so let's do a options. So encrypt file, they can have enter an EF. So EF would just be this, and then we can do in ET will be an encrypt text \n\t, and then we can do a decrypt at df for decrypt file. Then we can have a \n, a \t, \n \t, and then a D, and then a capital T for decrypt text, and then brute force will just be a B. You know what, to keep it consistent, I'll do tag B. Oh yeah, tag BF will be brute force file. And then lastly, we'll do a \n \t, and then a BT for brute force text, and then we can have a new line. You can hear the siren going in the back. All right, so that should be it. So if option, oh, that's going to be a lot to incorporate though. All right, so encrypt file option. I should swap that. Option encrypt file. So if we are encrypting the file, plain text, then we'll ask for plain file input. Oh wait, if we're not using these variables, then we can just assign them to the new value that the user can input. I think. I think. Because if they use a one-liner and encrypt, the encryption, do we ever use the plain file in here? No. Oh, okay, that might be fine. I mean, I guess we could still just make it its own variable, but I mean, for now, that should be fine. We need to fix that banner still. I don't know if that's right. It actually looks right-ish. No, yeah, see the P is off center. Yeah, we'll fix it later. Yeah, there's a lot of stuff we need to do. Okay. How do we... What am I doing again? I completely forgot what I was doing. Yeah, right, so that's right. We're setting up the CLI. So it looks like the plain text, like the... So encryption option. So this is the encrypt file option, right? Because argument 4 is 0, 1, 2, 3, 4. That's option to encrypt. And then the file, what's the file? 0? Oh, so if it's a file input, it's going to encrypt using files. And then else, we're going to if argue else, and then if I could just do an elif, but how do I want it, like, so if the arguments don't exist, or if the arguments exist and there's no file input, then we're going to need to use Cipher It's not cipher file, but cipher text. So instead of an if arguments equals 1, we're just going to be using arguments equals 1. So which means we can just do an if arguments 4 equals true, if arguments, if arguments, and then here we can say to encrypt the Caesar with the text variable. So that's arguments and then placement of 1 for the text, and then we're going to have to do a comma and then the key, which is arguments 3. So arguments 3. So the one-liners should be done. Can we try it out? All right. So if we do a Caesar cipher, if we do attack input text of hello and attack K for 5 and a, oh, K has to be a integer. K has to be an integer. int arg. Okay. There you go. So K5, and then we do an output text. Oh, I forgot to encrypt. Can we try that? Nope, doesn't work. Yeah, okay. It's not working yet. Option requires attack E argument. That's not right, because attack E. So if the option, oh, we get, oh, I see what's going on. So the attack E is expecting an arg's value, but you don't give E an argument value. That's gonna be, which means I need to make it a keyword argument rather than an argument. Okay, let me not forget that and go ahead and to do make these quarks. Okay, yeah, so we're going to need to make keyword arguments with these because they don't have an arg's value. Okay. So we'll figure that out later. Right now, let's finish incorporating the plain text version. I mean, not the plain text version, the CLI. Yeah. Have some water. All right. I guess we should, continue. I'll probably stop at like the 2 hour 30 minute mark, so I'll spend like 15 more minutes on this, and then do some other stuff. We'll see. Um, all right, dope. So let's figure out this CLI stuff. So if option is equal to EF, the plain text file is going to be equal to the input. So we're going to input their path, and then we're going to say the tilde to represent input, and then we'll say enter file name. There you go. Cool. And then we're going to encrypt Caesar with that plain file and their key. So their key is going to be their encryption. I'll call it shift. The shift key will be equal to input F path, and then tilde for input, enter encryption key, and then we will parse in the shift key. And there you go. That's the encryption done for that. So can we actually run this without arguments? Syntax error, of course. All right. Arg is not defined. Where is arg not defined? Line 1. All right, maybe it's just tripping. Run it again. Syntax error, invalid syntax. It says name error. Oh, that's from a while. Okay, let me run it on my command line. Control L. All right. So if we just run the Python Caesar cipher.py, no arguments, what happens? 165 and 162. (165) Caesar main, and then 162 CLI arguments exist. So what's going on in our, okay, so it happens in here. So we run our parser. Oh, it's having trouble with this. All right, can we comment that out? Do we need this args here? Is that what giving it the error? We can try that. Not enough values. Yeah, that's what I thought. All right, so Cipher file referenced before assignment. Cipher file equals arg. I define all the variables up here. Oh, is it because I named that other thing as a cipher file instead of giving it a new value? Where did I do that? Not only why did I do that, and where did I do that? Plain file. Yeah, plain file input equals, this will be input arguments equals parser. Oh, it's in the parser. Return this. Cipher file. Oh, okay. So where is the cipher file? We define it right here. And we also define them up here. So what do you mean? Oh my gosh, dude. All right. So the cipher file is giving us trouble. And why is that? If we assign the value of our argument and then we return it, we're just redefining them. Oh, it's not tabbed in all the way. Wait, no, it shouldn't be part of the for loop. No, wait, it shouldn't be part of the for loop. Once the for loop is done, for opt, args, and ops, if opt is this. Yeah, no, that's fine. It shouldn't, the for loop. Unless if this is what's giving it trouble. Oh, did I not uncomment that? Is that what's giving it trouble? It says, yeah, in the return right here, this file, cipher file referenced before assignment. The first time we assign it is right here. So, and we don't reference it before there. So even, oh, is it the none value? Do I have to assign it like a string value? Cipher file reference before assignment. Where are all the times we reference cipher file? Let me see. Control F, cipher file. We reference it 5 times. Once up here, if cipher file is equal to none with open. Oh, is this it right here? So if our cipher file is still equal to okay. So what if I change this to an empty string? And then it will print output text with open our cipher file. Interesting. All right, it seems like I'm stuck on this error. So I think I'm gonna just cut off here, kind of just chill, and then come back to it, tackle the error, and then record like an episode of like what we're doing here. This is just kind of like a stream, kind of like the preview of what we're doing. But let me actually switch to my face. So that's actually going to be it for this video, or the stream, I guess, right? If you guys want to see more progress or more updates of this, let me know. I'm going to try to make this into more of a series, kind of like devlogs. If you ever seen game developers do their devlogs, that's kind of what this is going to be like, but like with cybersecurity and developing a shell and a shell script, and all this other stuff. So it should be pretty fun. But yeah, that's going to be it. So make sure you leave a like, subscribe, and do the whole YouTube algorithm thing. And I'll see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.